Alright, so let's see how we can solve the lead array 30-day challenge question which is contiguous array. So here the question is, given a binary array, find the maximum length of contiguous subarray with equal number of 0 and 1. Okay, so first let's understand what this question is. Initially the example we got was 0, 1 and the output is 2 because we have 1 0 and 1 1, so totally two elements we have, which two elements that produce the same number of equal number of 0 and 1, right? And in this example we have 0 1 or 1 0. In that subcontiguous array has equal number of 1 and 0. Let's see one more example. Let me just delete this whole thing. Okay, so if you look at this example, all right, so if you look at this example, let me just delete that too. Okay, this is the array we have, and then these are the indexes for this array, right? So if from this example, what's the large subset of contiguous subarray which has 0 and 1? So initially we will say, okay, 0 1, it has only 1 0 1 1, so two elements, right? And then when we go here again, two elements, okay, and then when we go here we have 4 elements, and if we add this one we have totally 6 elements. That's the largest contiguous subarray which has equal number of zeros and ones, right? And so now that we understood the problem, okay, so here total length, the answer is length we will get 6, right? And the length we know that from the index 2 to 7, right? So 2 to 7 we have this many elements, right? And how we can solve this problem through the code, right? So in the brute force approach we will have two nested loops. In the nested loops we are going to track the ones and zeros, and then when ones and zeros are equal we are going to get the length between the indexes, and then we are going to have the maximum length, and we are going to get the given index length which is higher than the prior length or not, and based on the math.max function we will get the maximum length of the contiguous subarray using the brute force approach. And in that case we will have the time complexity of n squared. And there is another way we could write this code in big O of n time complexity, which means we can iterate the array only once. Okay, so before I write the code, I just want to give you a basic understanding how that code works. So the way the code works is we are going to have a variable, integer count variable, right? And then, so let me just write it here. Int. Initially we have this variable count 0, right? And then whenever we find 0, we are going to subtract -1 from this count variable. Whenever we find 1, we are going to add +1 to this variable. So whenever we find 0, we are going to subtract. Whenever we find 1, what we are going to do? Add +1. Okay, so why we are doing this is to find out the contiguous subarray. So there are two cases, we have two count cases we are going to have. Case 1, in this case we might get count is equal to 0. So when is the time we will get count is equal to 0? So let's consider this example. Okay, we have this 1 0 0 1. So what would happen initially in this example? We will have +1, and then when we have the 0 -1 0. So when I get the count 0, that means we have equal number of 0 and 1. And in that case, let me just even simplify this example here. Just only this, okay? If we consider this array, okay, for this count, so what's going to happen? If we consider this one, so what's going to happen initially? Initially the count is going to be -1, count is going to be, sorry, since it's 1, we are going to have plus 1, and then when we go to the 0th index, count is going to be what? Plus 1 minus 1 plus 1 minus 1, which is equal to 0. So when we get count is 0, that means we have equal number of ones and zeros, and in that case we could just increase the index I plus 1, because I am iterating this for this I have 1 comma 0 in the for loop, right? So initially I 0, when I is equal to 1, it's going to reach the 0th index, right? And then by the time the count is 0, then we will say I plus 1 is going to be our count value. That's the case 1, where we get count is equal to 0. And then case 2 we will have, so case 1, case 1 count is 0. Let me erase this example, you get the idea. Case 2, what is the case 2? The case 2 is the case when we are iterating through the for loop. There are some places we might get the same number twice. I'm going to go through this example, you will get the idea what I'm talking about. When we have the same number twice, between the given index we have this same, we have the equal number of 0 and 1. Okay, let's see this example. Okay, so initially, okay, I'm going to just put the index here and then count here. Okay, index and count here, and doing it for this example. Okay, let me just get this example here. This is for the case 2, okay, for this example. Okay, so initially when the index is 0, okay, we declare the count with 0, right? We declare the count, we initialize the count with 0 value, right? Integer count declaration, and we initialize the value 0 for that. And then when I'm in the index 0, I said if it's 0, I am going to subtract minus 1 from the count variable, right? So count is going to be equal to what? 0 minus 1, which is equal to minus 1. When I'm reaching the index 1, let me copy this real quick. Control C. Okay, when I'm reaching the index count or index 1, which is going to be what? When I'm reaching that index 1, again 0, so now the count is minus 1. Minus 1 minus 1 is equal to what? Minus 2. Alright, when I reach the index 3, now what is the index 3 value? Index 3 value, sorry, when I reach the index 2, excuse me, index 2, the value is 1. When I see 1, what I have to do, I'm going to add plus 1 to the count variable, right? So plus 1, now we are going to get minus 1, alright? So let's pause for a minute here and then see what's happening here. So we got this, we started with this minus 1, okay? We start count as 0, and then when we reach the 0th index, the count became minus 1, and when the array reaches the second index, again the count became minus 1. So now we have the same number of count between the index 0 and 2. What it proves us, when we have the same number, that means between these two indexes we have the same number of 0 and 1. So what does it mean between these two indexes? So 2 minus 0, we have two elements, like these two elements are equal number of 0 and 1. That's the reason we got minus 1 and minus 1. Okay, let me go back again and continue this, and it will make more sense when I go further. Okay, now the count is what? Minus 1, right? So minus 1, when I reach the third index, minus 1, so minus 2. So again we have this minus 2 and then this minus 2. In between the index 1 and 3 we have equal number of zeros and ones. Let me look at this here. Index 1 and index 3, between these two indexes 3 minus 1 2. So these two elements needs to have the equal number of 0 and 1. So minus 2 is in the when I am in the index 1 minus 2, when I am on the index 3 minus 2. So between these two indexes we have equal number of 0 and 1, right? And then when I go to the index 4, so now this is minus 2, right? Minus 2, right? What is the index 4 value? 0. So this going to be what? Minus 3. And then when I go to index 5, right? When I go to index 5, what's going to happen? When I go to index 5, now the count is minus 3. Minus 3, count is minus 3. And again, my 0, so minus 1, so minus 4. And then when I go to the index 6, what's going to happen? What's the value from the index 6? Index 6 has a 1. So whenever we see 1, what we're going to do? Plus 1, add the 1. Okay, so I'm going to add 1. So minus 4 plus 1 is equal to minus 3. So like I said, we have the equal number we find here between 4 and 6. Between 4 and 6, since the index 4 and 6 has the same number of count, we can conclude between the index 4 and 6 we are going to have equal number of zeros and ones. So here we are going to have equal number of zeros and 1 between these two indexes. Remember, between these two indexes, right? And then when I reach the index 7, what's going to happen? Minus 3 and then plus 1 is going to be equal to what? Minus 2. So let's see, here we have 1 minus 2 on index 7 here, and then here we have another minus 2 on index 3. Let's look at that between these two indexes. Index 3, index 7. So between these two indexes, so here, right, between these two indexes we have equal number of zeros and ones, right? Because in the index 3 we got minus 2, index 7 we got minus 2. So here how many elements we have? 1 2 3 4. Let's go a little bit up and then see here. I found another minus 2 here, which is in index 1. So I could clearly see between these two indexes there should be equal number of zeros and 1. So let's see, 7 minus 1 is 6. So these 6 elements needs to have same equal number of 1 and 0. So here 3 0 3 1. Therefore this is the maximum length of contiguous subarray which has equal number of zeros and ones, right? And let me write the code now, and then I'll go through one more example before I talk to the time and space complexity, right? Okay, let's write the code now. Let me minimize this. Okay, so what we're going to do is, first we are going to have int maximum length. Initially the length we don't know, we are going to say 0, right? And then int count is equal to 0. Initially count is 0, remember we have a count. And then I am going to have a map variable. I'll tell you in a second why I am using this. Okay, integer map new hash map. Okay, so if you look at this notepad, let me show you the notepad real quick. Okay, so the reason I am using a map is I want to keep I want to store the indexes and the count values when I am iterating the for loop, and then I could say check the count value whether you already exist or not. If it exists, I'm going to get the specific index value, and then I will keep track of the maximum length. All right, so that's the reason I am using this hash map to store the key value pair. So here the key is going to be my count, and then value is going to be my index. So key is going to be equal to count, and then value is going to be equal to index in my hash map. Okay, let me just put this in the code. Okay, so just make a note here. Okay, and then so these are the variables we need. Okay, and then I'm going to go ahead and iterate for int I is equal to 0 and iterate all the elements from the for loop, right? Okay, I plus plus. All right, and then what I'm going to do, if nums of I equal to 0, if we find 0, what I'm going to do, I'm going to subtract from the count, right? Int count is equal to okay, if I see 0, I'm going to subtract -1. Otherwise, I'm going to add control V. I'm going to add +1, because since this is a binary array, I'm just checking 0 and 1, right? Okay, and then what I'm going to do is, now that we know, we find the count. Remember, there are two cases. Case 1, if the count is 0, then maximum length is equal to what? I plus 1. We talked about that, remember? Alright, so I'm going to check if count is equal to 0, then the maximum length is equal to I plus 1. Else, now count is not equal to 0, we are in the second case, and then I'm going to check first if map contains key. We said key is the count. If we have the count, first I'm going to get the count value, max length is equal to math.max math.max maximum length, or remember between these two indexes, right? So I'm going to get I, the given ith index, minus map.get count. So this is going to give me the specific index that has the same value as the count. I am subtracting that from the given specific ith index and then assigning in the maximum length. Okay, if it doesn't have in the hash map, it doesn't have it, so I'm going to just put map.put. Remember, the key is the count and the value is the ith index, right? And then finally, what we are doing is, once we get out from this for loop, I am going to return the maximum length as an output. So this is the code that helps solve the problem of the maximum contiguous subarray. Before I explain the runtime space complexity, let's run the code and see if there are any errors I made. Integer. Oh, I missed the D, sorry, E. So when I go to the line 7 int integer, okay, then run. Perfect. So you answer and then expected answer is right. Let me run my example. I showed you this one real quick. Copy and then go and then custom test case. Control V. I gotta put comma, I guess. Yeah. Let me put the comma real quick. Comma 1, comma 0, comma 0, comma 0, 1, comma 1. Now run the code. I'm supposed to get 6 if I'm not mistaken. Six, perfect. Yeah. So this is how you can write the code to solve the maximum contiguous subarray. And quickly let's go through the time complexity. Okay. Time complexity is, okay, let's see. So here only one time we are going through the odd elements in the for loop. So big O of n is the time. Big O of n is the time complexity. And what's the space complexity? Space complexity is we are using a hash map to store the key and index, right? So big O of n is the space complexity. So I'm not going to submit the answer because I already did that. So this is how you can solve the problem. And please let me know if you find any corrections or any improvements. And I look at some examples through actual lead code solutions. That's really helpful. And on the internet there are some other good explanations to get the grasp of this problem. Thank you so much. I think that's it for today. Thanks.